Hello. This time we will be talking about arithmetic series, and that is the sum of the terms of an arithmetic sequence. Another lesson for Math 10. Okay, now we will do this activity. Determine the sum of the following set of numbers. Number 1. First 5 multiples of 6. So what are those numbers that are multiple of 6? So we have 6, 12, 18, 24, and 30. Now, if we are going to get the sum of these 5 numbers, obviously we will add from 6 up to 30, and we can get 90. So the sum of the first 5 multiples of 6 is 90. How about number 2? All odd numbers from 12 to 24. Okay, is 12 an odd number? No, it's not. So what's next to 12? That is 13. So is 13 an odd number? Yes. How about 24? Is 24 an odd number? No, it's not. So what is the number before 24? So that is 23. Is 23 an odd number? Yes, of course. So we will add all odd numbers from 13 to 23. So these are the odd numbers in between 12 to 24. 13, 15, 17, 19, 21, and 23. These are the odd numbers in between 12 and 24. So the sum is equal to 108. Okay, how about number 3? All whole numbers in between 20 and 45 that are divisible by 5. Okay. In between 20 and 45. Are we going to include 20? No, of course. Since we are going to add only numbers that are divisible by 5, which are in between 20 and 45. So what are the numbers? So we have 25, 30, 35, and 40. So if we are going to add all these 4 numbers, we come up with 130. So the sum of all whole numbers in between 20 and 45 that are divisible by 5 is equal to 130. Okay. So what is an arithmetic series then? This is the sum of the terms of an arithmetic sequence with a definite number of terms. And the formula for the sum of the first n terms in an arithmetic sequence is given by this formula. S sub n is equal to n divided by 2 times quantity, first term, plus the n term. Or, we can also use this formula. S sub n, or sum of n terms, is equal to n divided by 2 times quantity twice the first term plus quantity n minus 1 times d. Now, what do you think is the difference between these two formulas? Let's try to find out. Again, we have this first formula and we also have this second formula. Actually, in getting sum of the terms of an arithmetic sequence, we can use either of this formula. Okay? But then, now what do you think is the difference between these two formulas? Now we will go over to our two formulas. Okay, we have actually, as you can see, we have the shorter formula and the longer one. And a student, obviously, many of you will prefer on the shorter one. But we will go deeper on the differences between these two. Okay, so we have sum of n terms that is represented by, obviously, that is S sub n. First term, that is a sub 1 or a sub 1, or this is read as first term. Number of terms, that is n, represented by n. The n term or the last term, that is a sub n. And common difference, obviously, that is represented by d. As you noticed, for our shorter formula, first term and the last term are given. So if we will be dealing with problems in which first term and the last term are given, we will use this formula. Actually, this is shorter, so it's easy for us to solve. But then, if in our particular problem, there's no last term specified, we're only given the common difference in the first term and the number of terms. So no choice, we will be using this longer formula. Actually, either of these two, we can get the same answer. Okay, so let's try to solve this first problem. Find the sum of the first 10 terms of the arithmetic sequence 4, 10, 16. As you noticed, our first term here is 4. Number of terms, or our n, is 10. Why is it 10? Because we are going to find the sum of the first 10 terms. So our n is 10. So there will be 10 terms to be added. And our common difference here is 6. How did we get 6? That is 10 minus 4, that's 6. 16 minus 10, that is also 6. So our common difference for this sequence is 6. And we are asked to determine the sum of the 10 terms. Are we given with the last term? No, it's not. So obviously, we will be using the second formula. Okay. Sum of n terms is equal to n divided by 2 times quantity twice of the first term plus quantity n minus 1 times d. Okay, so that is how to read the formula. Now, substituting all the given values here, our n, or the number of terms to be added, is 10. So that is s sub 10. Here, our n is 10. So we will substitute n with 10. Then we have her 2. Just simply copy 2. And then our first term here is 4. Plus our n again, that is 10. That is 1. Minus 1 times d. Our common difference is 6. So we will replace d with 6. Simplifying, we come up with this step. 10 divided by 2, that is 5. 2 times 4, this is 8. This one, 10 minus 1, that is 9. Times 6. Next step is we are going to multiply 9 and 6. So 9 times 6, it's 54 plus 8, and that is 62. So we have for 62 times 5 is equal to 310. So the sum of the 10 terms of this arithmetic sequence is equal to 310. Okay. For the second example, we are going to find the sum of the first 50 natural numbers. Okay, take note, first 50 natural numbers. So obviously our first term is 1. Okay, and our n term is 50. Since we are going to find the sum of the first 50 natural numbers, so obviously our last term is 50. And the number of terms that we are going to add is actually 50. Okay, since we are given with first term and last term, we can apply the shorter formula, the n divided by 2 times quantity first term plus the last term. Or we can actually use the longer formula since we can easily get the d here, which is 1. But obviously, we will prefer to use the shorter one. So that is why we will use that first formula. Then substituting, we have n is 50. So 50 divided by 2 is equal to 25. Okay, 50 divided by 2 is equal to 25. Our first term here is 1. And our n term is 50. So 50 plus 1, and that is 51. So in our third step, we have here 50 divided by 2, it's 25. And then 1 plus 50, and that is 51. Next step is we are going to multiply 25 and 51. And so we come up with 1,275. So the sum of 50 terms, or the sum of the first 50 natural numbers, is equal to 1,275. Okay, how about number 3? Find the sum of the first 25 terms of the arithmetic sequence 4, 9, 14, 19, 24. Okay, take note, we are going to add only the first 25 terms. Are we given with the last term? No, it's not. So we have our first term is 4. Our n is 25. 25 since we are going to add the first 25 terms. So the number of terms to be added is equal to 25. So that is why our n is 25. Now our common difference is 5. How did we get 5? That is subtracting 9 by 4, which is 5. 14 minus 9, that's 5. 19 minus 14, that's 5. So our common difference is 5. Now we don't have last term. Okay, since we don't have last term, we're only given the first term and the common difference. We will apply this longer formula. This s sub n, or sum of n terms, is equal to n divided by 2 times quantity twice of the first term plus quantity n minus 1 times the common difference. Substituting with those given informations or data, we have our n is 25, this one. n will be substituted with 25 divided by 2. Times quantity 2 times 4. Our first term here is 4. Plus, our n again is 25 minus 1. And then our common difference is 5. Okay, so we are done substituting all those given informations. Next is we are going to simplify. So 25 divided by 2, that's 12.5. And then 2 times 4, that is 8. So we have our 25 minus 1, that is 24. Copy times 5. So in our next step, we have here, copy 12.5, copy 8. We will have this one first, 24 times 5, and that is 120. So next is we will add 120 plus 8, or add 120 and 8, so that this is equal to 128 times 12.5. So the answer will be 1,600. So the sum of the first 25 terms of our sequence is equal to 1,600. Okay? Next problem. Find the sum of all numbers divisible by 4 from 1 to 90. Take note, numbers that are divisible by 4 from 1 up to 90. Is 1 divisible by 4? Obviously not. How about 2? It's not. 3, of course, it's also not divisible by 4. So our first term here is 4, since 4 is divisible by 4. Followed by 8, followed by 12, up to 88. Why is that we will stop up to 88? Is 90 divisible by 4? No, it's not. And we are going to find only sum of numbers divisible by 4 from 1 up to 90. So therefore, we will not go beyond 90. Since 90 is not divisible by 4, so we're going to look for a number closer to 90, but not more than 90, which is divisible by 4. So that is 88. Now, from this one, we can have first term is equal to 4. Next, our n term or the last term is 88. And our common difference is 4. Okay, that's 8 minus 4, that's 4. 12 minus 8, that's also 4. Or simply, that's divisible by 4. So therefore, our common difference is 4. Now, how about our n? Actually, we can have 88 divided by 4, that is 22. So our n is 22. Or algebraically, we can solve for n by using the n term of an arithmetic sequence. That is, the n term is equal to first term plus quantity n minus 1 times d. Substituting, our last term is 88. First term here is 4. Number of terms, we don't know yet. We will just pretend that we don't know yet. We don't know yet this 22. So that's n minus 1 times common difference is 4. So simplifying, we have n times 4, this one. N times 4, that is 4n. Negative 1 times 4, it's negative 4. So we have 4 minus 4, that's 0. So what will remain here? We have 88 is equal to 4n. Divide both sides by 4 so that the numerical coefficient of n, which is 4, will be eliminated. So we have 88 divided by 4. So we have n is equal to 22. Or actually we can have 88 divided by 4. So we have 22 here. So this is only showing the algebraic procedure on how to get the n, the value of n. So again, we have this given informations. Our first term is 4, our last term is 88, our common difference is 4, and our n is 22. Now, to solve that problem, we can choose any of this formula again. The shorter one or the longer one. Okay, we are given with first term, we also have given with the last term. So we prefer to use this first formula. Okay, so we have our n here is 22 over 2. Our first term here is 4 plus our last term is 88. So we have 22 divided by 2, that's 11. Then 4 plus 88, that is 92. 92 times 11, so we have 1,012. Therefore, the sum of the 22 terms of our sequence is equal to 1,012. Okay. Actually, if we will be using the formula, this one, the longer one, we can also get the same answer. Okay. So it's 1012. Now, how about this problem? How many terms of arithmetic sequence 20, 18, 16 must be added so that the sum will be negative 100? This time we are given with the sum. We are not asked anymore to get the sum, but we are given with the sum. So what we are going to find out is the number of terms to be added so that we can have the sum of negative 100. So for our solution here, based on our problem, our first term is 20. Our common difference is negative 2. From here, 18 minus 20, it's negative 2. 16 minus 18, that's also negative 2. So our common difference is negative 2. And we are given with the sum of n terms, which is equal to negative 100. And in our problem here, we are going to find out how many terms we will add so that we can get negative 100. So same thing, we will be using this formula. The longer one, since we don't know what is the last term. We're only given with the first and the common difference. So we will apply this formula. Substituting, we have sum of n terms. We are given with negative 100. So we will substitute negative 100 here. Our n, we don't know. So it's n divided by 2. This is what we are going to look for. We have 2 here. And then first term is equal to 20. This one. Plus n minus 1 times our d, our common difference is negative 2. So this one. Okay, by applying the multiplication property of equality, here, we will multiply the whole equation with 2. So that this 2 here will be eliminated. So what will happen? We have negative 100 times 2, so it's negative 200. And then this 2 here times n over 2, this will become n. Since 2 over 2 will be 1. So what will remain here on this side is n. And then this 2 times 20, this is equal to 40. And this one here, using distributive property, we have negative 2 times n, it's negative 2n. This one, negative 1 times negative 2, it's positive 2. So after that, we are going to simplify 40 plus 2. So we have 42 minus 2n. Next, distribute this n. So what will happen here? We have n times 42. This will become 42n. And then n times negative 2n. This will be negative 2n squared. As you noticed, we are trying to make here a quadratic trinomial. So we have 2n squared minus 42n minus 200 is equal to 0. Now, to express this trinomial into simplest form, we are going to divide each term by 2, since 2 here is common to the 3 terms. So, divide 2n squared by 2, so we have n squared. Divide also this 42n by 2, so this will become negative 21n. Divide this negative 200 by 2, so we have negative 100. So our simplest form of this particular quadratic trinomial is n squared minus 21n minus 100. Now to solve for the value of n, we are going to factor this quadratic trinomial. By factoring, we come up with n minus 25 and n plus 4. So these are the two factors of this trinomial. So equating each factor by 0, so we come up with n here is equal to 25, and this other factor here is n equals negative 4. So these are the two values of n. And since we are going to find out the number of terms to be added to get the sum of negative 100, so which of these two terms is the most reliable value of n? So we are going to reject negative 4. Why? Because n here must be a natural number. We are asked to find out how many terms. There's no such thing as there are negative 4 terms. So we will reject that negative 4. So therefore, there are 25 terms of the sequence given 20, 18, and 16 up to the 25th term. We are going to add them so that we can get the sum of negative 100. So our answer for this particular problem, there are 25 terms to be added so that we can get the sum of negative 100. Okay. Thank you. I hope you learned something from this. This is Teacher Con.